Okay, so carrying on with example 13 on page 173, we've got to part E. Part E is find the distance moved by Q in the first 4 seconds, assuming that P does not reach the pulley. So what's happening here then is Q is moving down and P is moving up. How far does Q move in the first 4 seconds? Right, well, we found that both P and Q move with acceleration a fifth g. So a fifth g is constant, is a constant value, and so they're moving with constant acceleration, and so we can use the Suvat equations, which are for constant acceleration only. So really all we have is a particle moving with constant acceleration a fifth g. So we can say Suvat, this is part E I should say. Suvat, we can write down the values. We want to find the S. U starts from rest. V, well, we're not interested in the velocity. A, it's travelling at a fifth g, so 1/5 g, and we're looking to see how far it goes in 4 seconds, so t is 4. So the equation that doesn't contain v is S is ut plus a half at squared, and then S equals 0t plus a half times a fifth g times 4 squared, which is 16. So that is going to be 8/5g, which, if we make g 9.8, comes to 15.68 meters. Okay, so that's E. And the last bit's F. State how you have used the fact that the pulley is smooth in your calculation. Well, how you have used it, as I said before, is that the tension on both P and Q are the same. So in the equations of motion, when we write T here, and we write the same T here, that is because the pulley is smooth, and also because the string is light. So you need, in these questions, you need two conditions to have the same tension on both sides of the pulley. First of all, you need a light string, and also you need a smooth pulley. The inextensible string, that the way you have used that's often asked as well, is that both P and Q move with the same magnitude of acceleration. Remember, they don't have the same direction in this case, but they have the same magnitude because it's inextensible, and that's how you've used it. So how you've used it, well, what have you done in your equations? Because the pulley is light, you have written the same tension for each equation of motion. That's the answer to that question there. Okay, so this will enable you to do some of the problems in exercise 10F. Exercise 10F on page 175. Yes, in fact, you can do question 1, 2, 3, and 4. 1, 2, 3, and 4 are all no, 1, 2, and 3. Beg pardon. 1, 2, and 3. 4 is a different configuration, and involves a particle similar to the question on page example 14, where you have one particle lying on a table and one hanging, and the string passes over the pulley at the edge of the table. Now that is this question I'll do in the next video. Okay, thank you.